Hey there, it's Shannon MATHCHICK Myers, and today we're looking at plane curves and parametric equations. We currently use a single equation involving two variables to represent a graph. This tells us where an object has been, but it doesn't tell us where the object was in time, or at a given time, t. To determine this time, we introduce a third variable, t, called a parameter, using two equations to represent each x and y as functions of t gives us parametric equations. Definition of a plane curve: if f and g are continuous functions of t on an interval I, then the equations x equals f at t and y equals g at t are parametric equations, and t is the parameter. The set of points x and y obtained as t varies over the interval I is the graph of the parametric equations. So taken together, the parametric equations and the graph are called a plane curve. So just a note about domain and range of a plane curve. Domain of a plane curve ends up being the range of the equation x equals f at t and the range of a plane curve is the range of y equals g at t. All right, so let's take a look at an example. How it works: sketching the graph of a curve given by a set of parametric equations. So we've got x equals 2 times t squared and y equals t to the fourth plus 1. Typically t is over time, so we'll start t at 0. And if I plug in 0, I'll get x equals 2 times 0 squared, which is 0, and y would then equal to 1, just plugging in the value for t into the other two equations. So I'll go ahead and plot the point 0, 1 on our graph. Now, this is going to increase fairly rapidly, so I'm going to go ahead and just go increase by a half a unit till we get the feel for the graph. So when t is 1/2, we'll get 2 times a half squared, which is 2 times a quarter, which is 1/2 for x, and y will be 1/2 to the fourth, which is 1/16, plus 1, which will give us 17/16. And then if we want to, I actually found them earlier, sorry. 17/16 is 1.0625. So just for purposes of graphing, it's just over 1. Now if I plug in 1 for t, we'll get 2 for x, and we will get 2 for y. So we'll have an ordered pair. Ooh, I didn't graph the last one. So I have an ordered pair at 1/2 and then just over 1. And then we'll have an ordered pair at 2, 2. And then we'll just get one more point. We'll do 3/2. And when I square 3/2, I get 9/4. So I'll end up with 9/2 once I multiply that by 2. And then 3/2 to the fourth power is 81/16. And when I add 16/16, I'll get 97/16, which is approximately, what was on there? 6.1-ish. Cool so far? Awesome. Now, if t starts at 0, the domain of the plane curve will be the range of x, remember? So when we plugged in 0 for t, we got 0 will be less than or equal to f at t, which is our x, which is less than infinity. So basically x has to be greater than or equal to 0. And the range, given that start of t equal to 0, will start at 1. So 1 is less than or equal to g at t, which is y, which is less than an infinity. And so this is relating to domain and range of our plane curve. All right, so plotting this last point, we'll have 9/2, which is about 4.5, and then just over 6. So it'll be about here. And so we can make our graph. And you might be thinking, well, what's the big deal, right? I've seen graphs like this before, but we know a direction now. So as t gets larger, our graph will continue to increase. Good, good? All right, excellent. So our next step is to check out what this would look like if we were to eliminate the parameter, right? And so if we eliminate the parameter, what you do is you take x equal to 2t squared and y equal to t to the fourth plus 1, and we're trying to write them in x and y alone. So what I'm looking at here is I see that y has a t to the fourth, and I see that I can isolate t squared and so if I wrote y as t squared squared plus 1, and then I plug in what I found over there on the left side for x, which was x over 2. So t squared is x over 2. So I'll have x over 2, the quantity squared, plus 1, which gives us y equals x to the fourth Sorry. X squared over 4 plus 1. Now we will want to say that x is greater than or equal to 0, because in the equation with two variables, it would have been okay to put in a negative. But we know from our parameter we want to start with time equal to 0. Cool so far? I'm sorry, this is like a copy and paste error. I'm not sure what happened there. It happened when I was drawing the graph. Excellent. All right, here we go. Now let's look at x equal to cosine theta and y equal to 2 times sine at 2 theta. So we are asked to use our graphing calculator to sketch the curve represented by the parametric equations. And then, so we're going to want to look for the orientation, and we also need to put this in parametric mode. So in mode, we're currently in function. We go to parametric, and then we quit out of there. Now y equals will look different. So we are going to be working with our parameter is theta, but the automatic parameter in our calculator is t. So we'll just go ahead and use the automatic parameter. And then here we will have y is equal to 2 times sine at 2 times the angle, which we're using t. Cool so far? So when I graph this, I end up with this really cool graph, right? Let's look at our zoom. And let's look at zoom trig. Okay, so I put on the trace, and the trace is all the way over to the left here. And so if we look at calculate, we can see where we're at, and we're at t, or in our case theta is 0, and when that's going to be the starting point of our graph, and we'll get an ordered pair of 0, 1. And so as you continue, this will help us to see which way the graph orients. Do you see how it goes up and around and then back? And then it will complete when it gets back over here. Cool so far? And so if you look at just under, t is at 6.26, 6.28 is 2 pi. And it makes sense that the graph would complete in 2 pi since we've got one of our equations is cosine theta, which completes in 2 pi. All right, so we'll go ahead and take a picture of this. So we found that the graph started here, and we have to draw in the arrows for our orientation. Now, I believe on a regular TI-84 calculator, you wouldn't need to do that, but since I had the app, that's okay. It's good practice for us to figure out where our graph starts and how to draw in our orientation. Groovy? Awesome. And then now we're being asked to write the rectangular equation by eliminating the parameter. So we need to use some trig identities here. So we have one of the equations is x equals cosine theta. The other equation is y equals 2 times sine at 2 theta. So I know that there's a cosine theta in sine of 2 theta because I know my trig identities. So I'm going to rewrite this as 2 times 2 sine theta cosine theta using the double angle identity for the sine function. And x is cosine theta, right? So I can rewrite this as y equals 4 times sine theta times x, because x is cosine theta. Groovy? This is a theta, by the way. Looks sloppy, sorry. And I'll put some parentheses around it. Now we still have that sine theta, but I know a way that we can get to sine theta. We can square both sides so that we have x squared equals cosine squared at theta. So x squared will be 1 minus sine squared at theta. And then isolating sine squared at theta, I'll get 1 minus x squared if I switch them around a bit using some algebra. Now all I need to do is square this other equation to get a sine squared of theta. So then I'll have y squared is equal to 16 times sine squared at theta times x squared. And then y squared will be, and then if you remember, sine squared at theta was equal to 1 minus x squared times the x squared from before, and then rewriting it so it looks more pretty, we'll have y squared equals 16x squared times 1 minus x squared. Cool so far? So that one's, a little bit more on the mean side, but that's okay. You got this. Now, let's think about, now we have to think about the domain, right? So the domain of our plane curve is the range of x. X is equal to cosine theta. The range of cosine theta is -1 less than or equal to x less than or equal to 1. Cool, cool? And we are all done. Now, let's take a look. Let's go back to the graphing calculator and change our mode back to function. And notice that to graph this, we're going to have to do 2 graphs, right? Because we'll get a plus or minus. So if we go to y equals, we'll have second square root of 16 times x squared times the quantity 1 minus x squared. Oops. And that's our first one. And then our second would be the negative of that. And so our first one will be in green, our second one will be in the pink. So we'll have second square root of 16 times x squared times 1 minus x squared, all in the square root. So when we go to graph, we've got two colors, and if we click on the graph and we click on X to trace it, notice that it doesn't, it's going to trace one graph at a time. Do you see that? And we have no sense of the parameter theta, right? Just the variable X, okay? And X is cosine theta. And then you'd have to click onto that top graph to trace that one. So it really gives you a lot less information on that graph. All right, cool. So, all right, excellent. So this is the graph in function mode. And then just to remind you, if we go to our y equals, we had to graph it much differently. Cool? All right, moving on. Now we have this next one, and my apologies, I have a typo here. Y is equal to -5 plus 3 times sine theta. So please write that in. And so when we make our sketch, we'll start with theta equal to 0. It doesn't mean you can't start with a negative value. But this should give us if we go through to 2 pi, this should give us our whole graph because we have sine and cosine in here. So I'm going to do the quadrantal angles to get our values, and then we'll see how our orientation will go. So now when I plug in 0 for theta, I'll get -2 plus 3 times 1 for the first one, which gives me 1. And then I'll get -5 plus 3 times 0 for the second one, which is -5. So we'll be at 1, -5, which is over here. And then pi over 2, cosine theta zeroes out, so I'll just have -2. At pi over 2, the sine function is 1, so I'll have -5 plus 3, so I'll get -2 for y as well. So we'll be at -2, -2. At pi, cosine is -1, so I'll have -2 minus 3 is -5. And sine function is 0, so I'll be at -5. 3 pi over 2 will zero out the cosine function, so I'll be back at -2. And then at 3 pi over 2, the sine function is -1, so we'll have -5 minus 3, which is -8. So we'll be at -2 down at -8. And then at 2 pi, we should be back to our very first order pair, which was at 1, -5. And let's see, yes, because the cosine function is 1, -2 plus 3 would be +1. And then on the second equation would be at -5. So we're back to the start. So we know our orientation, and this to me seems like it's going to be a circle, right? Cool. And then when we put in the arrows for the orientation, if you recall, it went this way. And the center of the circle is right here, which is at -2 2, -5. So this is a circle with center, -2, -5, and radius is what? Beautiful. R equal to 3. Groovy? All right, so let's go ahead and see if we can find that from our eliminating the parameter. So oftentimes when you have the sine and the cosine function, you might need to use an identity, a Pythagorean identity. So always kind of keep in mind that cosine squared theta plus sine squared theta is equal to 1 as part of what you can use in your toolbox. So we had our equation was x equals -2 plus 3 times cosine theta, and then y was equal to -5 plus 3 times sine theta. And so I want to isolate the cosine theta in the first equation and the sine theta in the second equation, and then I can put it into that Pythagorean identity on the right there. So if I add 2, I'll get x plus 2 equals 3 times cosine theta. And then if I divide by 3, I get x plus 2 divided by 3 equals cosine theta. Sorry about my dogs. If I add 5 on the second one, I will get y plus 5 is equal to 3 sine theta. And then y plus 5 over 3 equals sine theta. And now, if I plug these in here, what will happen is I will have, in for cosine theta, I'll have x plus 2 over 3, and cosine theta is being squared. And then in for sine theta, I have y plus 5 over 3, and then that's all equal to 1, and then I'm squaring the sine function. So all I did is in for cosine theta, I put the x plus 2 over 3, and in for sine theta, I put the y plus 5 over 3. Groovy? Okay, and so this will give us x plus 2, the quantity squared, over 9, plus y plus 5, the quantity squared, over 9 equals 1. But that's going to give us x plus 2, the quantity squared, plus y plus 5, the quantity squared, is equal to 9. And if you write it, and this is our, result, and if you write it in the equation, that you're used to for a circle, you would have x minus -2 squared plus y minus -5 squared is equal to 3 squared, which is what we found before. Cool? Excellent. All right. So next up, we have x is equal to e to the 2t and y equals e to the t. So we want to use our graphing calculator to sketch the curve. We want to go back into parametric mode. And this time our variable will match. So we're going with, let's just clear these out. And then we'll have e raised to the 2 times t. Oops, I think I have an undo. Yay. And then on the second one, we just have e to the t. And then we'll go ahead and start our graph. And then our graph is starting over here now. So let's see what we have going on for t. So if I go to calculate, this is what happens when t is equal to 0, all right? And let's just take a look at what our graph will look like. All right, so nice looking graph, and we start right there when t is 0, and notice that t is increasing, and it seems to increase without bound. Notice that I made this to 100 and it's still increasing. So we've got our orientation is going to go from left to right. All right, and there's our graph. Let's write in that orientation. And now our task is to eliminate the parameter. So we had x is equal to e to the 2t. We had y is equal to e to the t. Now, if we look at x, e to the 2t is equivalent to e to the t squared, because when you raise a power to a power, you multiply. And that's what y is equal to, is it not? So you will have in for e to the t, we're going to put y. And so x is equal to y squared. And we're going to have to limit this to start with x greater than or equal to 1. Groovy? All right, so now next up is going kind of the other way around. Instead of being given an equation, we're being given characteristics about the graph, and we have to figure out what the equation is. So this one, we have a circle. We've been given the center and the radius. And so first of all, recall that we'll have x minus -6, the quantity squared, plus y minus 2, the quantity squared, is equal to 4 squared. Cool so far? And so this will just be x plus 6 squared plus y minus 2, the quantity squared, is equal to 16. Now if I divide by 16, I would get x plus 6, the quantity squared, plus y minus 2, the quantity squared, equals 1. And then over each of them, I have 16. Or under each of them, I have 16 rather. Now, remember the one we used before, cosine squared theta plus sine squared theta equals 1. So if I write these as one big something being squared, I could write it as x plus 6 over 4, the quantity squared, plus y minus 2 over 4, the quantity squared is 1. And then utilizing what I have on this side, that would yield that x plus 6 over 4 must be cosine theta, and y minus 2 over 4 must be sine theta. It's actually like a puzzle, right? All right, so here we go. Isolating the x, we'll get x plus 6 is 4 cosine theta. And then we'll get x is equal to negative 6 plus 4 cosine theta. Isolating y, we get y minus 2 is 4 sine theta. And then y is equal to 2 plus 4 times sine theta. So notice that these sine and the, I forgot my theta, sorry. That the sine and the cosine both have the same coefficient of 4. And so that might give us a clue that we're going to end up with a circle. All right? And so that is our set of parametric equations. Groovy? Okay. An ellipse with vertices 4 and 7, 4, 7, and 4, negative 3, and foci 4, 5, and then 4, negative 1. So I can clearly see that the major axis is vertical because there's shifting happening on the y coordinates here. And then just going by your definition, there's a shift on the y. K always goes with the y. And so k plus a, remember a is the in the equation for an ellipse, and the a goes underneath the variable that represents the major axis. So k plus a is 7, and k minus a is negative 3. So when I go through, I would get 2k is equal to 4, which gives us that k is 2. And then, what else will I get? I can find a. And so, if I use k plus a is 7, I found that k was 2, right? So 2 plus a is 7, and so a is 5. Groovy? Now, I have found out a couple of things. I have found out that the center of my ellipse is HK, which is 4, 2. I found K and I was given 4. Groovy? Okay. So now, here we go. We also were given information. So this was information from the vertices that we got information from vertices. All right. Now, we were also given information about the foci. And I know that the foci are going to be computed from the center, right? So K plus C has to equal to 5. All right, I already know K, so I don't need to make a system of equations. K was 2 from the past problem. 2 plus C is 5, so C is going to be 3. Good so far? Now, what else might we need to know? We need to know, awesome, we need to know B, right? just as a reminder, the general equation for an ellipse is, with the major axis vertical, is x minus h over the quantity squared over b squared plus y minus k, the quantity squared, over a squared. The a goes underneath the variable that represents the major axis, and that's going to equal to 1. So we need to utilize that. So to utilize that, we need to find b using the information about c and a. So recall that c squared is equal to a squared minus b squared. So that means that 3 squared is equal to, a was 5, and then minus b squared. We're squaring the 5. And so b squared will be 25 minus 9, and b squared will then be 16. And so b itself will be 4, but we'll just write it, we can write it in its squared form. Okay, so coming over here and finding and plugging everything in, x minus, we found h to be, h was 4, the quantity squared, over b squared. B we found to be 4, right? And then plus y minus k. K we found to be 2. And that is squared. And then a, remember, we also found in the blue. I'll just highlight that one. A was equal to 5. And so this will be 5 squared, and all of that is equal to 1. And so, making it a little nicer, we'll have x minus 4 squared over 16 plus y minus 2 quantity squared over 25 is equal to 1. And we're all good to go. Groovy? Excellent. We'll be covering the calculus related with plane curves and parametric equations next time. I hope you have a wonderful morning, afternoon, or evening whenever you're watching this show. And if you like what I'm doing, hit that subscribe button, that share button, and that like button. Bye.